Hello, ladies and gentlemen, and welcome to one of the highlights of this year's Formnext, the Pitchnext event 2022. The trade fair is once again full of innovation, trends, new machines, new materials, and much more. Driven by the big players in our industry, but also by now established startups that have stood on this stage at some point in their development and pitched their innovation with full excitement. For some, it was a starting point. For others, it was a clear validation of their idea, new food for their energy that drives these young companies and makes them successful. And all of this in front of an audience that came to the leading trade fair of additive manufacturing to experience just that. Established companies that are constantly developing and young companies with fresh ideas that are trying to revolutionize our industry, additive manufacturing. This event underlines Formnext's DNA of always keeping its finger on the pulse of time, which is the reason why it was obvious from hour zero to not only offer startups a stage, but also to actively promote them. In addition to this event at the AM4U stage, Formnext supports young companies with an attractive offer so that they can present their products or services to the world in the startup area. This year, you will find the startup area in Hall 12, B81 and Hall 12-1, B101. Another important pillar in the promotion and exclusive access to the startup area in this Pitchnext event is the Startup Challenge. Here, companies can apply with their idea and innovations, and the winners receive a free stand in the startup area, as well as an article at 3dprinting.com. For the past 2 years, there had been another important prize to win, which is also awarded here at the part of the Pitchnext event, namely the AM Ventures Impact Award, which was created for startups that particularly have a large impact on the topic of sustainability. For an event as important as the Pitchnext event, it naturally needs partners who make such an event possible in the first place. We would like to take the opportunity to give a big thank you to the partners. First of all, of course, to AM Ventures for giving out the AM Ventures Impact Award, and that's quite more important, for actively and constantly supporting the Startup Challenge itself. Next thank you goes to VoxelJet, who are printing our awards later for the Startup Challenge. For the first time this year, and this is worth an announcement and a big thank you, we will also give out a financial prize. This comes from HZG Group, who are sponsoring us for the first time and is a respectable €1,000 for the winning startups. Thank you very much for this prize money. Last but not least, a huge thank you goes to 3dprintingindustry.com for supporting our winners with a feature on their website. As you all can see, it's all about quality, which is why we do need to have an excellent jury, of course. Let me briefly introduce you to this jury. And they had a really hard time to select the winners, as we have so many good participants at this Startup Challenge. Stefanie Brickwede, at first, is head of additive manufacturing at Deutsche Bahn and also managing director of Mobility Goes Additive. And as we had her in the panel discussion this morning, I can confirm she is heavily driving the development of additive manufacturing. Then we have Dr. Christian Arndt, CEO of the Fraunhofer Center of Network Additive Production, Dr. Peter Meyer, Professor of Material Engineering from the Technical University of Munich, Alexander Oster, Director Additive Manufacturing of Autodesk, Michael Patch, Editor-in-Chief of 3dprintingindustry.com, and of course, Arno Held, Managing Partner of AM Ventures. Thank you to all of you for the, again, very difficult decision to choose our winners. One question remains for all of us: what is actually a startup, or who do we consider as a startup here at the Pitchnext event? The rules are relatively simple. A startup must not be older than 5 years, have a maximum turnover of 10 million euros, and not have a shareholding with a turnover that exceeds 10 million euro as well. In addition to the participants of the Startup Challenge this year, we have also startups from the area of the Federal Ministry for Economic Affairs and Climate Action, as well as the winner of the AMTC Pitchnext event, Fortius Metal, here on stage. Let's finally get to the program. There were no less than incredibly 20 exciting startups waiting for you here and at the screens, which we have divided into the categories of hardware, materials, and software. Afterwards, after the pitches, at around 4 o'clock, I have the pleasure of discussing the topic of startups, financing, and startup culture with 4 really important people of our industry, before we get then to the award ceremony for the Startup Challenge and the AM Ventures Impact Award at around 5 p.m. So let's get started. Each pitch will get 3.5 minutes, and I'm the nasty timekeeper, honestly. And you will have the opportunity to ask questions, and you at the screens as well. You can use the comment function, and I can see your question right here on the monitor, and I can ask them to the startups. So, first startup for the Pitchnext event from the hardware sector is the company Alpha Powders, represented by their CEO, Dominik Zdybal. They are one of the winners of the Startup Challenge, and I'm excited to hear about their solution. Dominik, if you are here, the stage is yours. Big applause for Dominik, ladies and gentlemen.
Welcome, everyone. My name is Dominik Zdybal, and I'm co-founder of Alpha Powders. We are here to join Industry 4.0 revolution. We founded last year with an ambition to become the manufacturer of affordable, high-quality powders for powder bed 3D printing sector. Quickly, we realized that the task is very difficult and very demanding. We came up with an idea to develop a technique that will allow to improve quality of polymer powders generated in low-cost manufacturing techniques, such as cryogenic grinding. Also, we realize there is a need for severely increased capacity of materials for production of powder materials for 3D printing sector. In order to achieve that, we came up with novel spheroidization technique, novel approach, more unique, more useful, more versatile, more stable than any other known technique for polymer powder spheroidization till now. Technique allows you to improve quality, that is sphericity, of not only cryogenically ground polymers, but also flakish dust waste materials generated by various industries. We want to make change now, so we decided to offer the solution to AM sector in order to allow all companies dealing with polymer powders to improve their products. The first product that we are offering is SpheroNano. This is a desktop, small spheroidizator meant for improvement of quality of powders developed by various R&D centers in different companies. We are starting pre-sale tomorrow, so feel free to contact us. If you want results already, we are open for in-house trial spheroidization. Because the solution is quite versatile, we offer it both to polymer manufacturers and 3D printer manufacturers. Also, we offer it to recycling companies. In order to secure lead times for SpheroNano devices and facilitate distribution process, we are starting close collaboration with Amazement company. SpheroNano will be devised with add-ins that may be quite interesting for you. It will have special package for processing of high-performance materials melting above 180 Celsius degrees. It will also have open system software that will allow you to perform research and finely tune spheroidization and rounding properties. My name is Dominik Zdybal, and I am CEO of Alpha Powders, responsible for strategy and innovation. My past experience includes co-founding of Progressive Space. Together with me, Alexander, CTO, expert in polymer processing and polymer technology, and Karol, business advisor and our insight into VC world. Together with this interdisciplinary team of founders, we gathered even more interdisciplinary team of employees that allows us to achieve our goals. Thank you for your attention.
Oh, no, keep it. We have probably some questions. So whenever you have a question, please raise your hand. I will see it and ask it. I have a first question. Dominik, I mean, you are going to pre-sale, so it seems that you're already very advanced. So
This is
This
is non-binding pre-sale. So basically, we expect to be offer a binding sale next year this time. Right now, we want to start not binding. However, we already offer in-house spheroidization using our Sphero Nano prototype. It still needs some work. It still needs investing into it. However, we are able to do small batches right now.
And what do you need as a startup? So while presenting it, cash. Anybody has cash with him? Yeah. No, oh, sorry, not yet, but probably afterwards. So there's a question from the audience online. How do you see the potential for combining your systems with computation and material discovery?
Sorry?
You have it there?
Yeah, here. Yeah, basically what is interesting here, you can modify your polymer powders with additives added to the powder before the process. This is quite a game changer because usually when you want to design new material for 3D printing sector, you need to start with compounding, pulverization, or solvent method. That makes it very long lead time process. Here, you can add additives to the powder using simple dry blending method, put that to the device, and create highly spherical, stable product right away. That may be important for people who are working with materials, for example, of increased electrical conductivity, or special magnetic properties, or special surface properties. There are actually infinite possibilities of modification of surface of the particle. Also, you can modify the bulk.
Great, thank you. There's another question, please.
Who is your competition and how are you different from them?
All right, so as far as competition is
So
considered...
let us quickly repeat the question for the people online. So what is your competition? How do you differ from your competition?
All right. So basically, when we consider competition, we should consider every company that is producing powders, and we should consider neither of them. Because when you consider this technology as a crucial link in powder manufacturing, every company that produces powders could be regarded so-called secondary competition. If we consider primary competition, there are some techniques known. For example, Japanese invention, I believe Japanese invention, it's called Nara. It's not melt-based, it's abrasion-based. There are known approaches from lab scale, like Downer reactor. Of course, there are approaches using wet methods, like co-extrusion. These methods are, of course, good, but they have some limitations, and our system overcomes these limitations.
Great. Thank you so much, Dominik. Congratulations for winning the Startup Challenge.
Thank you.
Dominik, applause,
Thank you very much.
please. Can leave the micro. Oh, take it with you. Take it with you. Yep. So coming to another winner of the Startup Challenge this year, much faster, much cheaper, combined with a high demand. This sounds very promising, at least from me. Let's take a short dive into microprinting and how photosynthetic will change the market with their approach. Dr. Magdalena Kurzyp, I hope I put the name correctly, responsible for business development fundraising, will tell us what we need to know. Magdalena, good to have you here. Stage is yours.
Thank you for this nice introduction. Hello, everybody. My name is Magda. I work at Photosynthetic, and today I would like to show you only one use case of our flexible micro 3D printing technology we develop at Photosynthetic. So nobody likes injections done by a conventional syringe. And moreover, this technology is more than 115 years old. the inefficiency of this method of injections drug to human body has been widely explored during the pandemics. So the queue you can see on the picture of people waiting to get vaccination. So in fact, there is a painless technology which can replace the conventional syringe. It's called microneedles. And basically, it's a patch with microstructures of tiny little needles we can put on our skin and transfer the drug via the skin. In fact, the main problem of this technology is that there is no production method able to meet the large-scale manufacturing. Also, the current methods lack the quality and reproducibility. So the simple solution to this seems to be the direct 3D printing, which is quite simple. It's one step, is direct, and also seems to be fast and inexpensive. Moreover, offers the reproducibility and scalability towards the massive large-scale production we need for replacing the syringe. So at Photosynthetic, we have been working on a novel approach. It's called volumetric. So instead of using a single light beam, we use 1 million light beams. It gives us advantage of the speed, so we can increase rapidly the speed of micro 3D printing, giving us the possibility to scale towards large manufacturing. The technology is well patented. Currently, we have 3 patents, and we have been working on this since 2019. For the moment, we are finalizing our MVP, and very, very recently, we printed the first structures. You can see prints of the first microneedles. This is a first trial, and we are very happy to show you this. We are very proud of these pictures. We currently have some launching customers and partners. Currently, 3 customers who are paying, 3 customer leads, and we identified more than 50 prospects within the microneedles market. Just one slide to show off a little bit. We have been recognized both by public and private sector. We recently received the Eurostars funding for the project with a total budget over 1.5 million to prove the feasibility of the production of microneedles. We have been also awarded some startup competitions and publication in conference in the past. In terms of the business model, our biggest ambition is to actually become a new manufacturing standard, including microneedles, with a revenue over 50 million euros. Within the next 5 years, we would like to capture 10% of the market. So to finish, I would like to ask you to join us printing the future at photosynthetic.nl and explore other possible applications of the technology. Thank you.
Big applause. Thank you so much, Magdalena. There's a question from the audience, as far as I heard in my ear. There was one question. No, then we have here on the monitor. So what is the primary challenge that must be overcome to 3D print at the micro scale?
So if we look at the conventional microscale 3D printing, we see that in terms of the microneedles, we have problem of defects and also large-scale production. So basically, yes, speed, large-scale production.
Very good. I think is there another question? Okay, perfect. Magdalena, thank you so much. Congratulations.
Thank you.
See you later at the award ceremony. So directly another winner of the Startup Challenge, and this is just occasionally, we didn't put them at the very beginning. So Valerio di Pompeo and his team at SphereCube promise a revolution in high-performance composite materials. We will find out exactly how this takes place in the next pitch. Valerio, I'm curious if you reveal some details to us.
Thank you for the presentation. The material have shaped the history. One example is a clay. The clay has shaped with turning machine to create some tools for it and drinks. Then, to improve the material and the high performance, 2 or more material has combined to create the best performance on material, such as composite or metal alloy. Hi everyone, my name is Valerio di Pompeo. I'm CEO and co-founder of SphereCube. And we want to reshape the future by 3D printing technology for high-performance composite materials. Actually, the problem in the composite sector is to create the part is necessary many steps to the process, up to 15 steps. It's necessary molds, and the process is mainly handcrafted. This is increase the time to market and the cost, and reduce the flexibility. To resolve that, we want to use the 3D printing in order to improve the high-performance composite material, the automation, less mold, adding material in order to increase the complexity of the geometry of the part. The market size is quite big, and we want to, in 5 years, reach about 33 million of euro, and the early evangelist is about in aerospace sector that we are validating, and is about 2,000 euros about. The idea is, and we are developing a software to improve the mechanical performance about our solution, optimize material such as filament and thermoset resin, and the 3D printer. Thank you very much for attention. See in our booth in level 12, B81, and we want to meet in order to have some idea about the POC. Thank you for attention.
Great, Valerio, thank you so much for the presentation. So how far are you with your product? That would be my first question. How advanced is it already? When can you start?
Yeah, the mechanical performance, specific mechanical performance, not to use the mold that in high-performance composite material is necessary, and reduce the steps of the process in order to reduce the time to market and the cost.
Great. Thank you so much. There's a question from the audience. Let me repeat that question. Very good. The question was, what is your business model? So.
Yeah. Actually, we are support the company B2B with consulting and selling parts. And the market, our goal is B2B, and we are validating the aerospace and racing sector. But the idea is to improve the sector, such as biomedical and naval and sports sector.
Awesome. Thank you so much, Valerio. It was a pleasure to have you. A great presentation. See you later at the award ceremony. Thank you so much.
Thank you very much.
So I like names very much, so I'm very interested in the next company, because the word free in their company name has definitely something to do with their innovation. I'm curious to see what 3D printing is changing and which application they will approach first. Michael Rieger, CEO, will lead us from 3D printing to 3D printing. Michael, stage is yours.
Hello, thank you everybody. My name is Michael. I'm one of the co-founders of 3D printing, and we print with robots, bigger, more stable, and with less effort, even on complex surfaces. As you all know, there's a common modeling pattern, one modeling paradigm, with horizontal, even and flat layers building up from one direction. And this is due to the reason is that there is a limitation of the systems restricted to 3 linear axes usually, and the software that is only adapted to this kinematic. And the drawbacks that comes with it is in modeling direction, you need the support structures, as you know. You have the problem that you only can print on horizontal and flat surfaces usually, and most of the part characteristic like tensile strength and surface quality are defined by this modeling paradigm. And our approach is we are using a robot with six axes, and we are bringing this kinematic and this modeling freedom to the modeling process, and we are overcoming this modeling paradigm with variable modeling patterns with freeform layers. Here you see a video of our booth and our prototype and the robot moving the process head and building up the model with freeform layers. And by doing that, we have the potential to reduce or to avoid support structures and have the possibility also to print on curved surfaces, not just on horizontal and even layers, faces. And we can also combine different layer orientations in one part, and by that, optimizing and affecting the part characteristic, like the tensile strength or the surface quality. And right now, we are already in contact with several partners, for example, with the MedTech. Application cases are prothesis and orthesis, also from the automotive industry with prototypes and pre-series and many more. And maybe also your business case, your use case can benefit from that. We are always searching for new application cases and new use cases to identify more of them, which use case can benefit from our technology. So yeah, we would be happy to discuss that with you. Meet us at our booth in Hall 12.1.
Awesome. Big applause for 3D printing. Thank you so much. Awesome presentation. Do you have a robot with you to showcase?
Yeah, it's at our booth.
Awesome. Yeah. You should see that. Is there any question from the audience so far? Anyone? I think we don't have. There's. Yeah, go ahead. Feel free. It's a pleasure, by the way. The question was which materials they can print.
So right now we are printing with a material extrusion process, the common plastics material, but we can transfer this kind of modeling process also to metal-based processes like laser metal deposition or wire and arc additive manufacturing, and we are working on that.
And there's another question from the online audience. How does use system improve on the Stratasys robotic composite 3D demonstrator? If you know it, I don't know.
Yeah, we know that. How does the system improve?
I think, so, where's your system better? I think this is the question, isn't it?
Yeah, okay. It's about the software and about the strategy of modeling. And we believe the strategy of modeling with the features presented, the three ones, this is what we believe is better than other solutions we see on the software side, because for our solution, our modeling, as a user, you don't have to set any modeling direction. So it's totally, the control program is totally calculated automatically.
Awesome. A last question from the audience. Will you have a low-budget version for this kind of 3D printer technology? I like this very much, to be honest.
Maybe later on, but so far it's an industrial additive manufacturing system, of course. Maybe not meant for each and every 3D printing personal printer, to be honest. Yeah.
Awesome. Awesome presentation. Thank you for answering the question. Michael, please, an applause. Honestly, I've always the highest respect, in particular for startups that want to make a difference in the medical field, as they sometimes have to overcome even greater hurdles. At the same time, with their products, they have a great influence on the most important factor in our lives, health and the related joy of life. How Plasmics contributes to this, their CEO and founder, Konrad Schreiner, tells us. Konrad, good to have you back again. Stage is yours.
Hello, my name is Konrad Schreiner. I'm the founder and CEO of Plasmics. So, who's ever here had an ill-fitting shoe, high heel, ski boot? Anybody? I suppose there are a couple. But you know, if you or I have this problem, we just go out and get another pair of shoes. However, there are people who are not so fortunate. There are 108 million people out there who do not have prosthetics at the moment. There's a massive undersupply. And this is due to two factors. First, the this human object interface, the thing which actually fits to your body, it takes approximately 8 to 12 weeks to produce and costs on average $2,000 US. However, we changed this. We bring down the costs and the time. We can produce the same thing in 3 days by producing on site. But how do we do that? Well, we combine our unique technologies, being induction-based nozzle and our machine learning, with our software together to produce the best quality part possible with FDM 3D printing. This is a demonstration of how our quality control process works. Basically, we analyze layer by layer, and then we compare it against what the optimal solution would look like. Yeah, it's going to finish. And then we can create a report to show, okay, we are actually up to spec or we are not. We recently launched our nozzle, which is induction-based, the first one in the market. It's really groundbreaking, and we have our patents are also tied into this 3D printing nozzle. And this is not just an easy feat. It's actually a pretty hard problem, NP hard problem, to be honest. But we have the great team for that. We have material scientists. My co-founder, Stefan Spohr, would be in this category. But we have a team of another 15 people strong to facilitate this, as well as advisors. However, if you think about certified production on site, wherever this may be, then you can produce not only prosthetics, but you can produce other products, like, say, insoles or other orthopedic devices. And you're not bound to produce in-house, on-site, and sell elsewhere, but you can basically sell the machine and then locally design and produce your IP and sell it globally. Yeah, this is what we do at Plasmics, and I'm really happy to have your questions.
First, an applause. Excellent presentation. Thank you, Konrad. Come a little bit over to me, please. So my first question, before we ask probably the audience, because I'm following up this last year, I'm really highly interested in your solutions. If you compare now the prosthetics, the one that is like produced in the 12 weeks period of time and years, is there also an improvement in usability and user experience? Because it's quite important for the one that is getting it. Is there a difference with using 3D printing?
There's little a man cannot do with their hands, but it's going to take ages, it's going to take time, and it's going to take money, therefore. But we have an integrated approach where we can combine also softer and harder materials in one print. So it's very easy to combine everything in one print, and making the things available is, for somebody who is not having a foot, it's really more important to have it.
So right now it's more about availability and speed, and not about the real quality comparison between the original method and this one.
We have been specializing in multi-material printing, so we already have 3D printed circuitry inside those objects, but this is just like 2 more steps ahead. It's more important to deliver tomorrow than it's to have the most intelligent prosthetic there is.
Awesome. In my opinion, very important. There's a question from the audience.
Really good question.
Can we repeat the question for the audience?
So it's basically about the process control and the report. It's not only the process control and the report, but the report was more or less a side effect of what we're actually trying to accomplish, and having a full cycle machine learning loop. So basically, we're feeding that information back into the slicer, which is cloud-based, analyzing it there, and feeding it back into the G-code of the next layer.
Awesome. Thank you so much. Konrad, it was a pleasure to have you back here again.
Thank you very much to have me again.
See you probably next year, no? See you. Bye-bye. Thank you. Big applause. Serious production in metal 3D printing. I assume each and every one of us has asked this question, is that already in place? Do we seeing that? So far, still not really implemented in my point of view. So ValCUN wants to overcome a few hurdles and move into previously unreached market segments. Definitely exciting. Let's take a look at the realization with Jonas Galle, CEO and founder of ValCUN. Jonas, stage is yours.
Thank you for the introduction. Sorry?
Perfect. Yeah.
Okay. So I'm Jonas from ValCUN, CEO and co-founder. And actually, I'm always triggered by metal 3D printing because I see a lot of potential in it. But I also see a lot of hurdles yet, and that's basically what we try to solve with ValCUN, because we want to bring metal 3D printing towards serial production in an economical way. And to do that, we first have to look at a couple of hurdles that we identified. And actually, we focus initially at aluminum, because aluminum today is somehow understated. There are so many applications on aluminum, and to be honest, printing aluminum is kind of a pain in the ass for a lot of technologies. Second thing is hardware. So far is still expensive because the use of lasers. So we want to bring that down. Also, that comes to the productivity, because if you have a fast machine, it can be more expensive. The problem is most of the technologies today are quite slow with an expensive machine. So that's not really beneficial for serial production. Another thing is the feedstock as well, because a lot of technologies use high costly feedstock, which is not necessarily necessary to come to serial production. And the technologies that use powders, a lot of people say additive manufacturing is good to reduce a CO2 footprint. But if you look at what it costs in terms of energy and CO2 footprint for making powders, for example, you would be amazed how sad it would be for additive manufacturing. And the next thing is safety. As you see on this picture for powder bed fusion, they're wearing masks in order to avoid health issues, but also it's sensitive to explosions, these kind of things. And the next thing is automation, because your process itself can be efficient, but if you have to do a lot of things, pre-processing, post-processing, it might affect your capabilities to go towards serial production. So how are we dealing with that? So here you see a movie of our process, and basically it's FDM 3D printing, but instead of using polymers or powders in a polymer binding, we use direct molten metal that we deposit in a controlled way. And in that way, we can actually print aluminum quite efficiently, because actually the fusion energy is coming from the printhead itself. So as you know, aluminum is highly conductive. So it's like filling up a bath with the tube plug open. Here we actually use all the energy inside the printhead, deposit the material, so the only extra energy we need is to have the fusion. It's quite simple technology as for FDM. The only thing you have to do is melt the metal inside the printhead. That can be quite straightforward. So the productivity is basically the same as in FDM. So we have demonstrations of a print nozzle of 7 millimeters. We have gone very much slower, so we can have the same resolution as classic FDM printing. For the feedstock, as we print everything in a nozzle, it doesn't really matter what we feed towards the printer. At the moment we use wires, but that can be anything else. In terms of CO2 footprint, if you take aluminum chunks, you don't have to do the whole process to go towards powders and the extra energy that's needed to do so. In terms of safety, we don't have splattering of plasma stuff or powder that's flowing around. So in that way, it can be basically in open air. And I will come to the next video I have here that demonstrates really the automation capabilities. As we print it basically in ambient atmosphere. We can simply change the hot swapping after printing, as the process is not affected by thermal stresses, we can use very light build plates to print our parts on this. So the part being printed is the one I have here. So that's how we are going to encounter.
I need
serial
to do the
production.
timekeeper. You're already far over the time.
Okay, I'm
Sorry.
so enthusiastic that I
Probably just one last remark,
Yeah.
and then
So where we are in the landscape of the serial production towards the complexity, it's the empty space we want to close towards larger series, but also more complex parts. And to give a reference, if you compare ourselves to milling, we see from the business cases we have that about when there is 70% chipping or more, then our technology becomes more interesting, even with post-processing included. And for die casting, we see that we are more economic, up to 3 to 5K of parts, depending on the application and needs. So that's all I wanted to say, and I have to leave.
it was still a great presentation, right?
Yeah.
We need to work on the timing, that's for sure.
Yeah, you're right.
Yeah.
Yeah.
Thank you so much, ValCUN. Thank you so much.
Thank you.
Great for having you. And we can visit you at your booth and ask our questions there.
Yeah, exactly. So,
Thank you so much.
thank you.
Applause for you. Sorry for that. Everybody has the same rules. So we're coming to our last startup in the hardware sector. So real-time monitoring of the mechanical properties of transformed materials. That's what Mach3D, I hope I put it correctly, promises on their homepage. Matteo Vettori, is it correct? I hope so.
Perfect.
Thank you so much. CEO and founder tells us how they make it happen. Matteo,
Thank you for the nice introduction.
You're welcome.
So people, I saw you a bit sleepy, so I would like to help you with your food coma, just with a quick walk throughout industrial production. My name is Matteo Vettori, I am the CEO of Mach3D. This is an FFF additive manufacturing production. This is an SLS MJF production. This is an SLA production, and this is a metal additive manufacturing production. Then we jump in the space in the International Space Station, in which where they have an additive manufacturing lab. What do they have in common? They are transforming raw materials into final product with a single-step process. Moreover, there are no facilities to perform material testing directly there. Material testing is a key to detect anomalies into materials that have to move to industrial productions. Today, material testing starts from specimens that are tested onto complex and dangerous machines that generate curves from which then engineers are able to extract the mechanical properties. You can do this in outsourcing with long time to response and fixed cost, or in-house with a huge investment for mechanical testing solutions, laboratories, and qualified personnel. Today, traditional material testing solutions for cost, complexity, and timings are not ready for industrial production and not accessible for small, medium enterprises. Mach3D is a smart material testing platform with 3 magic features. Its size, extremely compact, allows Mach3D to be placed everywhere in every company. Thanks to our patented fixture, the test is made easier, safer, faster, but still accurate. Thanks to the cloud, results are immediately shared in the company, can be correlated with process parameter, and then we can enable optimization and industrial process monitoring and correction. We are a team of engineers, 2 founders, mechanical engineers with a PhD in material testing and non-conventional materials. Then the team is completed with marketing skills and software skills. We have a mixed business model. We sold in one-off our hardware. We generate recurring revenues from the cloud platform and the artificial intelligence features. Mach3D will be a network of sensors collecting data that are feeding our data pool, on which artificial intelligence could generate more and more values for our customer and then for us. We are in the material testing market that suffer huge of the entering barriers we stated. In Europe, in additive manufacturing and plastics, we count more than 100,000 companies. The 60% of them is ready to invest in material testing with a budget comparable to the Mark 3D budget. This makes for us in Europe a 1.5 billion market ready to be achieved. We differentiate for the ease to use and the maximum load to cost ratio, and for our cloud, we have now a validated, patented, and certified hardware, the first industrial and academic application, first customers, and first market traction. We want to enter the market in Europe for the next 3 years, while completing our product. We need a 1.5 million euro ticket for doing this. This is Mark 3D, the revolution in material testing.
Awesome. Thank you so much.
Thank you.
Just in time. I really like the last one because this will be my next question, what you really need, because it seems already everything very advanced.
We have everything clear. Yeah. We just need the money to do our project.
Very good, very good. Any questions from the audience so far before I ask my question? No? Do you have already customers in place where they are using it with their machines, beside the ones that you have your first customers? Yeah. So can you give us an example how they use it?
We actually have made two rounds of beta testing. The first round was supposed to give back the machines to us. The second round, we just have been able to solder the machines at the end of this testing period. One customer is manufacturing resins for additive manufacturing. The second customer is building small metal parts and is using Mark 3D at the end of the manufacturing process. And the third customer is an academy that is using for research and teaching.
Very good. Awesome.
Thank you.
Thank you so much, Matteo. It was a pleasure to have you here. Mark 3D. Big applause.